Hey guys, I am making this video today to talk about Unit 5, and Unit 5 is Chapter 9 and 10, so it may be two videos. We'll just see how quickly I talk through it. So I sent you all the files for what I'm going to be talking about today. One of them is just my notes, kind of just like a quick summary of Chapter 9 and 10. And then the other one is the practice test for Unit 5 and the answers for that. So that's what we're going to be using for this one. Remember, there are also lecture videos that you can watch. So this is not necessarily to replace those, but kind of just to summarize it. Or if you've already watched those and you're going through homework and maybe just have a few questions here and there, this may help. All right. So first of all, I just wanted to talk about the fact school is almost over, right? We're in week 14 right now. Today is April 22nd when I'm recording this. So don't forget that all due dates have been extended until the end of the semester, which is May 8th. That would be the Friday of the last week. So that means we have about 2.5 weeks left of the semester. Right now, you should be working in Unit 4 or 5. Somewhere in the chapters from 7 through 10 is where you should be. Technically, we would be in Unit 5 right now, finishing up the Unit 5 test. And then next week, which would have been week 15, in class, we would have been reviewing for the final both days. And then, of course, we would take our final exam on that Monday or Tuesday of week 16. But since we're doing stuff at home now, you have a little extra time to work on some of that because you could take the final exam on Friday of finals week, right? You don't have to take it Monday or Tuesday. So you have a few extra days there to kind of play with. Next week, because we won't be meeting, of course, in person, I am going to schedule some Microsoft Teams meetings that you're welcome to join. Of course, it's optional, but we're going to talk about the practice final exam and just any questions you have leading into the final, or questions about Unit 4 or 5, really anything that you want to ask about. And so those can be come and go. The good thing about Microsoft Teams is that you can use the video and stuff on your computer or on your phone or whatever, but you also can just call in if you just want to hear what we're talking about. So you can do that. You can do either way. I'll also send out a digital version of the practice final exam. I think most of you all, because we did have half of the semester together in lecture class, may be more used to having our practice exams as paper things to look over and stuff. So I'm going to go ahead and send that out to you all later this week or the beginning of next week. And that's also what we can talk about on the Microsoft Teams meeting. The final exam, though, will be taken in MyLabs Plus, and you will have 2 hours to complete it, and you can only take it once. So, make sure you're ready to take it when you take it. I am going to be working on updating the grade book. As you know, the MyLabs and the Blackboard grade book do not communicate. And honestly, I kind of slacked off on that and kind of forgot about updating the homework and quiz grades. But if you've been working a lot on homework and quizzes, maybe ones that you hadn't finished before spring, that's not going to be reflected in the grade book. So I'm going to try to go through and start updating those as much as I can so you have a better idea of what your current grade is in there. And so I just wanted you to know, if you have been working on stuff and you don't feel like your Blackboard grade book is changing, that's probably why, because I haven't done that. So I'm sorry about that. And then I have asked for, but please complete the course evaluation for this class in Blackboard. So it should be, once you click into our course, it should be kind of at the top and you just click on it. It's a quick survey. You all have had classes here before, so you've probably taken them a million times. But, we do use those every semester. Our dean gets to look through those, and kind of see how our classes were evaluated, but the teachers will also look at them just so we know maybe what you all liked or didn't like, and how we can improve things in the future. Especially this semester, of course, we've had kind of the tale of two halves of the semester, right? Because the first half was normal and the second half normal. But you can comment on either one, if there were certain things you liked about the online version of our class, lecture version or whatever, you can just let me know either way. Okay, so I'll take any of that feedback. And of course, it's all anonymous and we don't get it until after the semester's over. So you won't be penalized for anything you say. All right. Okay, so moving into chapter 9 here. Okay, so chapter 9 and 10, if you're okay with chapter 7 and 8, chapter 9 and 10 is just going to continue on kind of what we talked about in chapter 7 and 8. 7 and 8 introduced the normal distribution and then sampling distributions and talked about how those were related. Now what we're going to do in chapter 9 and 10 is work more with our inferential statistics, using a statistic to estimate the true parameter, right? And what we start off with in chapter 9 is the difference in a point estimate and a confidence interval. So what we've been doing so far is using point estimates. So like we would do a study and we would have one statistic, right? Maybe we would have a percentage or we would average, but we're going to have one value, and that would be called our point estimate. And so we're using 1 point to estimate what that true parameter is, right? The problem with that is, though, that our point estimate could be wrong, right? So we take one poll and we get that percentage, but we're not ever really sure if that one number is the true parameter, right? It's just an estimate, and it's just one estimate. And so what we go into is using confidence intervals, and confidence intervals will give us a range of values where we think the true parameter is, right? And so then we have more confidence in our answer, because instead of just saying, I think the true parameter is 20%, and we're thinking in our minds, well, that's probably not, it's probably off a little bit, but we don't know for sure, right? The confidence interval would instead say, I think the true percentage is between 15 and 25%. So of course you're not as exactly sure what the number is, but you have more confidence that the true parameter is somewhere in that interval. Okay, so I just did a quick example here. So one says 40% of people have a savings account. Another study done a year later says 43% of people have a savings account. And so what some people might do is they might look at this and say, well, the study last year said 40%, now it's 43%. So I guess more people have a savings account now, right? Well, as they studied everyone, we have to remember that both of these values are statistics, right? They're just estimates of the true parameter. So we don't necessarily know if one of them's right or both of them are right or neither are right. And so we really need to think about how sampling works, right? And so one of the first things we talked about back in chapter 1 is how there's sampling error, right? And so every sample has error, and that's because a sample is not the population, right? A sample is trying to describe the whole population, but it's never as good as getting the entire population. And we talked about that as you increase sample size, your sampling error decreases, right? It gets a better and better estimate as you increase your sample size, but sampling error never really goes away. So we're always going to have sampling error, okay? And so that's why looking at 2 studies, we couldn't just say, well, yes, compared to last year, it went up 3%, so that must mean more people now have a savings account. Well, it could just be that the study last year was off a little bit, right? And the study this year was off a little bit, and maybe there's tied still, or one's, maybe last year's study, actually the overall parameter would have been greater than this year's. So what we're going to start looking at with our sampling error is something called the margin of error. And so margin of error is just the way we're going to calculate sampling error. And so we know that every sample is going to give us a little bit different result. Sometimes that is because there has actually been a change. Maybe there has really a higher percentage now with a savings account, right? But it could also be due to the fact just taking another sample, okay, in every, so let's prior study that I was mentioning, let's say it had a margin of error of plus or minus 4%, okay? So plus or minus 4% means that our statistic could have been off by 4% above or below, right? So our margin of error is always a minus number because we know our statistic could be off, and it could be off by being too high or by being too low, right? So in our statistic would be, the statistic I gave was 0.4. So we could add and subtract our 4% here. And that would say that in study 1, we thought that between 36 and 44% of the population had a savings account. In study 2, okay, the next year, we got a statistic of 43%. But when I add and subtract that 4%, I get anywhere from 39 to 47%. All right, so we still don't know what the true parameter is, but we are pretty confident that it's between, one of these two values. So when we compare those, like on a number line, you would see that study 1 is going from 36 to 44. Study 2 is going from 39 to 47. And so you notice that they have a lot of space here where they cross, right? So it's possible the true parameter was here in study 1 and still here in study 2, right? So it's possible there hasn't been a change at all. It's just that our samples were a little different each time. So if we had these to compare, once we include the margin of error, we would say because these two intervals cross, they're not completely different, right? They have some similar possibilities. And so that means that they are not statistically different, or there has not been a significant increase. All right, so those would be two of the outcomes. You would either be saying they're not statistically different, or there's not been a significant increase. One of those two things would be our conclusion. Okay, now with this one, I just gave you a margin of error, and sometimes that's going to happen with the margin of error. Like if we're reading a study, a lot of times at the bottom, like a Gallup poll or something you might read in the newspaper, it'll tell you what the margin of error is. And so then all you have to do is just add and subtract it to the statistic. But if we're actually creating it on our own, what we're doing is we're taking our print, which in this case is p hat, so that's our sample proportion, and we're going to add and subtract the margin of error. And the way we get the margin of error is it's based on our level of confidence, and that's where this z alpha half comes from. Our level of confidence is telling us how wide we want the interval to be. So like 95% confidence is going to be a smaller range of numbers than 99% confidence, because the more confidence you have, the larger the interval becomes. So, you try to understand the formula, or you can just know that you can calculate this using the one prop z interval in your calculator. Okay. So either one of these is the same answer. Okay, so if we're doing proportions, we want to use the one prop z interval. So one prop z interval is actually in a little bit different place than where we've been going. In the last chapter, we were using the distributions tab a lot, right, for the normal CDF and the inverse norm. But this is actually back in stat. So if you go to stat and over to test, that's where we're going to have what we're going to use in chapter 10, which is up here. And chapter 9 stuff, you have to go down a little bit here. And so like this one right here, we're doing one proportion because we just have one p hat. And then we're doing a z interval because we're using the z here from the normal distribution. Okay, and so that's how we would do it. Now for means, to create a confidence interval for means, or for mu, our point estimate there will be x bar, that's our sample mean, right? And then we're going to add and subtract our margin of error here. The margin of error for this is t alpha half times s over the square root of n. So these are our standard from the sampling distribution. That's what these both are. So if you go back to the sampling distributions that we talked about in chapter 8, you should be able to see how those are related. And of course, I talk more about that in the regular lecture videos. But we are using the t distribution here instead of the z, or the normal distribution, because we're using s instead of sigma. And because we're using S, we see that there's a lot more variability in the distribution for smaller sample sizes. And that's a long thing we could talk about, but again, you can find that in the regular lecture video. But again, this formula will give you the same thing as the t-interval will give you in the calculator. So again, that's going to be in the stat area in test. And I skipped it, it's up here. And you go to the t-interval there, and that's what you're going to use for that one. All right, so let's go to the practice test and look at stuff for chapter 9 at least. So really, the concept behind confidence intervals and then hypothesis testing in chapter 10 is kind of difficult. You know, if you're really trying to understand what does a confidence interval mean, or some of the stuff behind hypothesis testing, but the actual calculation of the interval or the hypothesis test stuff that we'll get to is not real difficult because it's all just in the calculator. So as long as you can kind of remember the steps to put in the calculator and then kind of how to interpret the output, that part shouldn't be too bad. But sometimes when your answer has to be in a certain like sentence form or whatever, it can get a little more tricky, and just trying to interpret what the question is asking you to do can be difficult, but the actual calculation of the interval shouldn't be too bad because you should just be using your calculator. Okay. So this first one here on the practice test says a retirement community takes a random sample of 25 up its risk and finds the average age is 74. The sample standard deviation is 9.8. Calculated 99% confidence interval for mu, round to 1 decimal place. Okay, so here it says we want to create an interval, right? So we know we're doing chapter 9 for mu. Mu is means. Also, if we look up here, we see that it says the average age is 74. So that's a sample mean, right? So we're talking about means again. It also says the sample standard deviation is 9.8. So anytime we're given a standard deviation, that means we are talking about averages and means. Okay, if we don't have a standard deviation, then we're talking about proportions. So the important data I put over, so we have a sample size of 25, we have sample mean of 74, sample standard deviation of 9.8, and we want a confidence interval, a 99% confidence interval. So our confidence level is going to be 0.99. So if I go to my calculator here, I'm going to go to the t-interval. All right, and there's two options here. Now, most of the time we're going to use stats here. Stats means that you know what the sample mean is, and you know the sample mean, and you know the sample standard deviation, etc. Okay, but if you have a problem, like some of them are in the MyLabs, where you actually have data given to you, like you just have the data, but it hasn't calculated the mean and standard deviation yet, then what you would do is you would go to Stat and Edit, and you would type your data in to L1 or L2, whatever you want to use, and then go to Stat and Test, and then go down to your t-interval and choose data, all right, and then tell it my data is in L1, and it'll pull that and go ahead and calculate your mean and standard deviation. So it does it all in one step instead of you having to calculate it and then put it back in and all that stuff. So but most of the time we will be using stats because that's how most of our problems are set up. All right, so looking at the information we have, so everything I wrote here is pretty much what we need to put in, right? So we'll have 74 for the mean, 9.8 for the standard deviation, and 25 for our sample size. Remember, for the C level, that's your confidence level, you always want to put it in as a decimal. If I was to put it in as like just 99, it would give me an error. Okay, so make sure you are putting it in as a decimal. And then calculate. Sometimes it takes a second to calculate the t. And then that's our interval. Okay, so this is the lower bound of the interval and that's the upper bound. So we're 99% sure that this interval contains the true mean, right? So it says around to 1 decimal place. So I said it's from 68.5 up to 79.5. So we think the true average age is between 78.5 and 79.5. So there are two ways you can write this. Now you're going to be giving your answer on MyLab, so it will kind of determine how you're going to write it. But if we were doing this on paper, you could write it where you just kind of and it says it goes from here to there, or you could write it here, in an inequality form. You could do that too. So either answer is kind of giving you the same thing. All right, so moving on to the next one, it says, now the next one is talking about proportions, which you probably could guess because the other one was means. But again, we're going to look at some things that would let us know if it's proportions or means. So here it says, a recent study showed that 61% of college students use their phones for studying. So in these type of problems, sometimes they'll give you the percentage and sometimes they'll give you the X value. If we're doing it in our calculator, we X value instead of the percentage. So it's nice if they give you both, but if they don't, then you might have to calculate one or the other. But anyway, that's what this number is. The sample size for the poll was 2657, created 95% confidence interval. College students who use their smartphones to study. Here it says we're doing an interval for the true proportion of all college students, right? We also have percentages here, and you notice that we're not given an average and we're not given a standard deviation, so it would be really hard to do this for means, right? Because we don't have any of this information that we're used to getting for that. So we're gonna do proportions, right? And so the important numbers here are the sample size, the X value, so how many people actually did say yes or whatever, that they do use their phones for studying. And then the p hat, if we needed it, like if we were doing this by hand, is 0.61, right? That's the 61%. So in the calculator, let me move this over here. Sorry. All right, so doing this one, we're going to go here to stat test and go down to 1 prop z interval. All right, and so it's going to ask for the X value, which is 1621. The N is 2657. And then we are doing a 95% confidence interval for this one. All right, and we're going to round to 2 decimal places. So we think the true P is between 59 and 63%, right? So that would be our interval, 0.59 to 0.63. And that's really it for confidence intervals, making sure you can identify if it's means or proportions, and then identifying all the important numbers, and then knowing when to use the T interval or the 1 prop Z interval. Okay, I'm going to go down to the last question here. Maybe. So the last question, because it'll be proportions, I'll do another video to do the hypothesis test. Okay, so the last question here, we're looking at an article. This one was back from the fall. But in a lot of these polls, especially when we're talking about presidential approval or who you're going to vote for in the election, etc., if there's a lot of different possibilities, you may end up with a lot of candidates that have very similar numbers, right? So this one says that they're statistically tied in national polls. And so it may be something that you've wondered before, or maybe now that you are, doing statistics, you may have thought about, well, what does statistically tied mean? Because does that mean they are tied, or they're just statistically tied? What do they really mean by that? So in this example, we have that Biden was at 23%, Warren was at 23%, and Sanders was at 20%. So we can obviously see how Biden and Warren were tied, right? They both have 23%. But why is Sanders also considered tied with Biden and Warren when they're 3% above him? Right? And so what statistically tied means is that when the margin of error is factored in, there's not a statistical difference. Okay, so it means that the difference between the values are not any more than just the margin of error. So there could be a difference between the values, or it could just be due to sampling error, right? And so that's what we would see down here. If we were to add the margin of error, which was given here, it said the survey had a margin of error of plus or minus 5.3 percentage points. And if it has a margin of error of about 5%, that means they had a pretty small sample size. Because if you have a sample size of 1,000, then you usually have a margin of error of about 3%. So they must have had a sample size for that one. All right, so here I added the margin of error for Biden and Warren. It would be the same, right? So their percentages are anywhere from about 17.7 up to 28.3. And then Sanders, when it's added in, his is anywhere from 14.7 up to 25.3%, right? So what we can at these intervals cross, right? They do have some common outcomes. So that means there's not a statistical difference in the results. So even though Biden and Warren were ahead of Sanders in this particular poll, it doesn't necessarily mean that the population percentage for Biden and Warren is greater than Sanders. Okay, it means that at this point, there's really not enough data to tell if one person is really ahead of another one. So you need a difference that's greater than the margin of error, basically. We would need them to be ahead by 6, 7, 8% to be able to say there is a clear leader, right? All right, so that's all we'll cover in this one because we haven't covered chapter 10 yet. I will send out those links for a meeting next week. Of course, anytime you want to talk, if you'd like to do some sort of Microsoft Teams meeting, we can do that individually. If that's something you think would help you, I can do that. And, just let me know if there's a certain time or date or whatever that works for you. But I'll send out the links, and so you can join those next week if you want to. Be working on Unit 5, Chapter 9 and 10, trying to get to the Unit 5 exam using this practice test to kind of help you along and see if you have any questions about any of the material there. And then all we'll have left is the final exam and just preparing for that. All right. So please let me know if you have any questions and I will get this posted, started on the Chapter 10 video and summary, and then that'll be it. You'll know everything you need to know about statistics for this semester, right? So I miss you guys, and I wish we could be together to finish out this semester because it's always kind of a fun time of year. It's stressful, but it's also fun because we're getting ready for graduation and summer and all that. So it is kind of sad that we don't get to end it together, but at least we can kind of virtually be together, I guess. So be sure to email me if you have any questions, and I will see you all soon. Thanks.